review our or that you work on your practice. And today we did lesson 12. Honestly, like because of how I did the rest of the lessons in the unit, we could have skipped 12 entirely. But Mondays are short days, so I figured it was good to do anything. At least if we got to the very end part, so that you could see a system of equations and how to solve them by graphing. Not all of my classes got to the end. So I will recap that, and then I'll let you work on your practice. But you should have noticed that we had a real world situation. Stop talking. We had a real world situation, and we had to make an equation to represent it and fill out a table of values. So not all of us are good problem solvers. Not all of us can think like, oh, all I have to do to get that is divide 15 by 8 to get what I need. So that's why making the equation is a helpful thing to know how to do to make you a good problem solver. And you have to do it on your test, like there's just no way around it. You have to be able to identify totals, put them alone on one side of the equal sign, and see what contributes to that total. All of you should be looking at the screen. All right, we filled out a table of values accordingly. I showed you how you can do it with algebra, like what is shown over here, plugging in and solving for the other variable. Or I showed you how to do it with a graph. Both have their pros and cons. Like here, unless you're really good at your algebra, you might make a silly mistake. Graphing, you still have to know how to read the graph. So like there's pros and cons to both approaches. But then this one is the one that not all of my classes got to finish. You had a new constraint introduced. So now Diego's buying a total of 2 pounds. And you'll notice each of these, when you add them together, they add up to 2. Because if they're buying 0 pounds of raisins, then the 2 pounds must be all walnuts. If they're buying 0.75 pounds of raisins, the other 1.25 must be walnuts. Like it has to add to 2 for this constraint. Now, there's only one pair of numbers that works for both constraints. That meets the budget of $15 and that has him buying 2 pounds. And that was this one. All right, so here it is on this screen. Here it is for the other one, just to show you. So when you look at each constraint alone, there's lots of different combinations of answers you can have. But when you look at 2 sets of constraints together, that's where you only have one answer that works. And that's what we call a system of equations. So a system of equations has 2 different equations with the same variables. Again, you should be looking at my screen, giving you new information. System of equations are 2 different equations, sometimes more, but they have the same variables used. So when that happens, you have a few different options for answers. You could have one solution where they intersect at just one spot, like this. Notice that's the same thing we got from our notes when we did the tables, that this meets both constraints where they intersect. 0.25 pounds of raisins, 1.75 pounds of walnuts. But there's also other types, and we'll explore those other types in the next few lessons, but just in case it shows up on your homework. So here's what it looks like when there's one solution, they intersect at one spot. If they never intersect because they're perfectly parallel, they have the same slope, different y-intercepts, there's no solution. And if they end up creating the same line, like maybe the equations are something that produces equivalent equations, like you could rearrange one to get the other, and it looks like the same line is graphed, that's because they're right on top of each other. That's where you have infinitely many. All right, so to summarize, where they intersect is where their solution is, whether that's infinitely many, one solution, or no solution because they don't intersect at all. All right, questions on that? All right, I think that should be enough for you to be able to do your practice. You may or may not be able to finish your practice because, you know, math lab's a short class, but, or on Mondays, it's a short class. But you could always save your questions for tomorrow. I'll just kind of, if you have questions as we go, I'll help you, but I don't think I'll do like the check-in at the end. Tomorrow, I can do the check-in for any practice you want to do, but I just feel like today you're just gonna be trying to work on it. So let me know if you have questions as you go. Any questions right now?